Alright, we're going to take information about a hyperbola and use that information to find all the other parts of the hyperbola as well as graph. Okay. Now when I say list all the parts, I'm going to list what I can think of as being what you would list for a hyperbola, but it varies between textbooks and things might go by slightly different names and such, but the ideas are all still the same. So keep that in mind as I work this example. So I'm going to actually use a graph to make my list and kind of build both of these, the graph and the list, simultaneously. I'm not going to fully do the graph and then make my list. That's too difficult because I have to do some work to be able to graph, so might as well go back and forth. Okay, so let's go ahead and put a graph in here and plot what's given. I'll plot these three pieces in black. So the center is at 2, 4. I have a focus at 2, 9, a vertex at 2, 7. So I have a vertex and a focus. Now, the center to the vertex, that's my A value, so that distance is 3. So I can go ahead and come over here and say that A equals 3. Also, the center to a focus, this distance here, is my C value, which is 5. So I can come over here and say that C is 5. Alright, so furthermore, so this is my center, which means I have symmetry around it. If I go 3 units down from there, I'll get my other vertex. So here's my other vertex. And if I go 5 units down from that, I'll get my other focus. Okay, so let's go ahead and list some of these things over here. So I have the center, which actually was given, so let me write that in black. Okay, the center is the order pair 2, 4. The foci, one that was given is 2, 9, and the one that we've determined ourselves is down here at 2, -1. We have the vertices, one of those was given as well. That was 2, 7. The top one over here, and the lower one is the order pair 2, 1. Okay, so we're off to a good start here. Now I can also figure out my transverse axis. My transverse axis goes from vertex to vertex, so that's right here. Now I need my conjugate axis, the horizontal piece here, which means I need my B value. So I need my B value to finish this graph and to finish off finding all the parts. So the way to find B is to use the equation c squared equals a squared plus b squared, because I already know A and C up here. So I've got 2 of the 3 parts of this equation. I just need to figure out what B is. So let's plug these in. C is 5, so I get 5 squared equals A, which is 3 squared, plus my unknown B squared. So 25 equals 9 plus B squared. Subtract 9 from both sides to get 16 equals B squared. And take the square root to see that B is 4. So now I've got my B value. My B value is measured perpendicular to my A value, which was measured up and down. So both of these guys, A and C, were measured up and down, which means that B will be measured left and right. Okay, so I'll go 4 units, 1, 2, 3, 4 units to the right, and 1, 2, 3, 4 units to the left, and now I've got my conjugate axis as well. Okay. Furthermore, I can draw my center rectangle. It's right here. Again, this was my transverse axis and this was my conjugate axis. And once I have my center rectangle, I can draw my asymptotes. So they go through the corners of the rectangle and through the center of the box. Okay, so there's one of them. And let's talk about the equation of this asymptote. This asymptote passes through the center. We're going to use the center here as our point, okay? The reason I'm using the center as a point of reference is because my other asymptote also goes through that, so I can use the same point. The center is the point 2, 4, which means in the equation of the asymptote, x is 2, so the x part of the equation is going to be x minus 2, and the y part of the equation is going to be y minus 4. Use the opposites of these values in your point slope form. So if you haven't watched a video on point slope form, you may want to go do that if you're not familiar with it. So the equation of this asymptote is going to be y minus 4 equals some number, the slope, times x minus 2. So now we just need the slope of this line. So I need my rise and my run. So my rise, I'll use this distance, and my run, I'll use this distance because I know both of them. So I go up 3 units, so my rise is 3, and my run is 1, 2, 3, 4. In fact, your rise and run are always your a and b values. However, your b could be your rise and your a could be your run. It just depends on the problem. Okay? So this is the equation of that first asymptote that we see here. And I don't mind for my students if they leave it in this form, but most textbooks will go ahead and get y by itself. Okay? So get y by itself. So I've got y minus 4, and I'll distribute my 3/4. So I've got 3/4 x minus 3/4 times 2 is 3/2. And finally add the 4 over. So I've got 3/4 x plus 5/2. So that's the equation of one asymptote right there. Again, for my students, I wouldn't care if they left it like this. However, it's very common to get y by itself like this. Now we need the equation of the other asymptote, which is very similar. Once again, this asymptote goes through the center, so I'm still going to use this x and this y in my equation. So I'll have y minus 4 equals my slope, which we'll determine later, times x minus 2. Now the slope of this line, start at the center, your rise is actually negative and your run is positive. So now my rise is negative 3 and my run is positive 4. And it's always true that the only difference between the two equations are the slopes are opposites. One's positive and one's negative. So you really don't have to do it twice. If you know one, you just use a negative slope in the other one. And again, you could leave it like this if you're one of my students, or you could get y by itself like most textbooks do. So distribute negative 3/4 and add 4 again. To get negative 3/4 x plus 11/2. So that's my other asymptote. So now I've listed both of my asymptotes using point slope formula, which if you don't know, you might need to go look up, okay? But I've illustrated here how to use it. Use the center as your point, and then use your slope to get the slope, of course. Alright, lastly, we just have to graph the curve. So the curve passes through both of my vertices, which are up and down, and wraps around my foci. So my curve is going to wrap up, or open up and open down. So on top, I need to wrap around my focus and approach my asymptotes there. And on bottom, the same thing. It will open down around its focus. So there is my hyperbola. Alright, so you start with your center, go up, down, left, and right, get your box, draw your asymptotes, graph the curve. You may need to use the equation c squared equals a squared plus b squared to determine one of those three values if you know the other two.